Hello again. The sharkC64 language has now model inclusion, so one module can use other modules. Let's have a look. As an example, let's have a look at a color module. It defines color codes as constants. Each color constant is mapped to a byte value that represents that color. With model inclusion, we can now use these definitions in another module. This module paints the words Commodore and Basic with other colors on the screen. It includes the colors from the color module with a used statement. Then the color constants can be referred to by using a fully qualified name. The first part of the name refers to the module and the second part refers to the constant identifier. For instance, here the fully qualified name refers to the light green constant defined in the color module. As for the rest of the program, it defines a constant and variables that are used for painting the words. The actual painting is then done with two loops in the main program. Let's run the program. In the module inclusion, each module can be included only once. Consider for instance a module like this. It includes two other modules. Then the module inclusion reads first the module B. Suppose that the module B also includes other modules. Then the module inclusion continues by reading next the first included module in the module B. Suppose that the module D has no other module inclusions. Then the module inclusion continues with the module B. Now suppose that the module C includes yet another module. Then that module is read next. Let's assume that the module E includes no other modules. Then the module inclusion backtracks all the way back to the module B. Now it tries to include the last module mentioned in the module B. However, as that module has already been read, it can be linked without reading it twice. Next, the module inclusion backtracks to the module A. Now it tries to include the last module mentioned in the module A. As that module has already been read, it can be linked directly. Although it looks like any module can refer to any other module, that is not the case. The main restriction is that the module inclusion cannot form any cycles. Let's have a look at another case. Here the module inclusion continues as before. When the module C is read, the module inclusion runs into a problem. The module C tries to include the module A. However, as the inclusion of the module A is still in progress, a cycle is formed between the modules. That is not allowed and this causes a compilation error. As for the compilation, the biggest change with the use statement comes with the fully qualified names. Consider for instance an assignment like this. The lexer first passes that into tokens. Then the parser creates a syntax tree from the tokens. When building the syntax tree, the parser recognizes a fully qualified name and includes that to the syntax tree. The syntax tree is then passed to the binder that uses the current module scope for the non-qualified names. As for the fully qualified names, the binder uses the module information to bind the identifier to the correct module scope. When the binding is done, the resulting object graph can be simplified as each identifier is technically now fully qualified. The object graph is then passed to the translator. The translator takes the object graph and creates a program fragment by using the intermediate representation language. Each identifier is now fully qualified, so the name reference for an identifier contains now also the name of the module. In this particular example, however, the color constant reference gets replaced with its value in the intermediate representation. Lastly, the program fragment is passed to the generator. It then generates the bytecode from the program fragment. So that is what the use statement looks like in the sharkC64 language. As for the next step, I will extend the development environment with a new feature. Anyhow, thanks for stopping by and see you soon.